let's look at how much power you actually get from a wind turbine at different wind speeds and the different types of wind turbine. So here is a graph showing the power of the wind passing through our area A, and it goes as velocity cubed, so it rises very sharply as the wind speed increases. But what does the turbine actually get? Well, here is a typical wind power graph. So first of all, when the wind is going very slowly, it's not enough to get the turbine spinning at all, so you get no power. That's the cut-in wind speed, the minimum speed at which you can operate at. Then you're talking about your typical maybe 40% efficiency up here. But then when the wind gets really strong, instead of keeping rising, it turns over and there's the rated power. This is the maximum power the wind turbine is designed to operate at. Now, why not just spin the turbine faster when the wind is stronger? Well, first of all, the wind is not stronger very often, so it doesn't make much difference to the total energy output. But also, the faster your turbine is spinning, the stronger it has to be, otherwise it might fly to pieces. And the bigger the generator you need at the back, because that's going to be generating more and more electricity. If you have too much electricity, it might melt the copper wires, and you might need a bigger generator with more magnets and so on. So, in practice, they're designed for a certain wind speed. And what happens is there'll be a large range of wind speeds where it's basically working at its rated power. The way it does this is the rotor blades can change their tilt, and they'll change their tilt to mean they have to spin less at the really strong wind speeds. Then eventually there's going to be a wind speed which is so fast it's in danger of actually destroying your wind turbine. At that point the rotor blades are feathered, which means they point edge on to the wind, so the wind is no longer turning them. That means if there's a hurricane going past or a gale force wind, you won't be getting any power from your turbines. So what this means is you can divide the power we get from the power in the wind and get a turbine efficiency curve. And you can see that for a particular turbine, this is what's called a Class 2 turbine, it's got good efficiency, between 40 and 50%, over a wind speed of 5 to about 11 meters per second, and then it tails away at larger wind speeds. At larger wind speeds, it's actually producing the same amount of power as here, as you can see there, it's a smaller fraction of the wind power that's going past. So that's the typical turbine efficiency. But turbines come in three classes. So if you go to a turbine manufacturer and say, I want a wind turbine, they'll ask you, what class do you want? So a Class 1 wind turbine is designed for very windy sites with an average wind speed of more than 8.5 meters per second. Class 2 for medium sites, between 7.5 and 8.5 meters per second, and then Class 3 for low wind sites. Now this is just an approximate rule of thumb. It also depends on extreme weather predictions. Like you've got to design not just for your typical wind speed, but what's the most you can get. A region which is liable to get hurricanes, you might have to have especially strong and well-braced wind turbines to avoid them being destroyed. So here's the efficiency curves for the Type 1, high wind, medium wind and low wind, Class 3. And you can see the graph is basically just shifted to the side. The Class 1 high wind turbines are just designed to be more efficient at higher wind velocities compared to the other ones, as you'd expect. Now, if you assume the rotor diameter is the same for all of them, here's what the efficiency curve looks like. Basically, it's a small difference over there. The Class 3 is more efficient, but the power is still very small. The main difference is how far up they can go, how fast they can be spinning before you have to say, okay, no more power, and start feathering the rotor blades. Now, why do you do this? Why not just use Class 1 everywhere? Because you might get a windy day, even at a normally calm site. The basic trouble is that Class 1 turbine would have to have a larger generator, a dynamo, than a Class 2 or Class 3, because when it's spinning faster, it may need to have more electricity coming through. And that's expensive. That generator is a large part of the total price of the entire system. It's just not worth speccing a large generator for a site that doesn't often have high wind speeds. The benefit just doesn't justify the cost. Also, generating very high amounts of electricity puts a lot more stress on the rotor, tower, foundations, gearbox, which means they're all going to have to be built more strongly, which means it's more money. This is because it's extracting more momentum from the wind. So thus a Class 1 turbine needs to be built more strongly and more solidly than a Class 2 or Class 3, which costs money. And again, that's worth it if you're on a site that's going to give you a lot of wind power, but if you're a less windy site, it's just not worth it. So the Class 2 and 3 are going to be cheaper. But there are also advantages to the class 2 and 3. For a given generator size, which is measured in terms of the power, let's say you've got a 3 megawatt generator, the class 3 turbine will have a larger rotor diameter than a class 2 or class 1. It can afford to have a larger one because it's not so windy, so it doesn't have to be so strong. A very large, fragile one that can survive at a class 3 site would get blown to pieces in a class 1 site. So you can get the same power in a low wind site, you just build a bigger turbine, and you can build a bigger turbine at a reasonable price because it doesn't have to be so strong. However, there is still a drawback. The larger rotor means you have to have more space between one turbine and the next because it produces turbulence behind it. You can't put these things too close because they interfere with each other, and because they're bigger, that means you have to spread them further apart. So if you've got a given site which is a certain number of square kilometers of ground, you can get more class 1 or 2 turbines than you can class 3 into it.